Okay, hello everyone. I understand I should be live now. So I'm Rakun, and I'll be talking about dispelling a misconception, non-human animals as intelligent, cultured, and moral beings. And the motivation for this is basically, I think there are many people, particularly in the general public, not so much in the furry fandom, that see animals as sort of unthinking and unfeeling. And so I want to sort of fix that. So if you want to actually keep track of me after this, I'm on Twitter, Furry, Ink Bunny, Flavor. They're all for different things. And one question you might have just before we start is that, you might say, oh, Rakun, you're not a zoologist, you're not an ethologist. Ethologists are the people that study animal behavior. And that's true, but I'm still a scientist. So some of it sort of overlaps. And in science, one of the more important things is not sort of your title and degree, but it is the evidence that supports whatever claim you make. So at the end of this, I'll share the slides, probably just put a link in the chat. And in those, you'll find for each one, there's links to all the pictures, videos, papers, and so on. So if there's anything you think, oh no, Rakun must be lying about this, or maybe you think, oh, that's really interesting, I want to know more, you can easily follow up on that. Okay, so let's get started then. So what exactly is this misconception that's been going around? So we'll start with the philosopher René Descartes, most famous for saying, I think, therefore I am. But he also had some things to say about animals, which were not particularly complimentary. So, for example, he's been quoted as saying, seeing that a dog is made of flesh, you perhaps think that everything which is in you also exists in the dog. But I observe no mind at all in the dog, and hence believe there is nothing to be found in a dog that resembles the things I recognize in a mind. Now, he was pretty much wrong about that, but he was quite influential, and it led to this belief that animals were basically just automatons that had no feelings, no thoughts, no conception of pain. And that led to some rather unfortunate things, such as the practice of vivisection, where people would actually cut open, for example, a dog with no anesthetic, just restraining it to study what's going on inside of it, which was great for studies of the circulation, terrible for the dog. But okay, Descartes was in the 1600s, right? So maybe we've advanced a bit in the last 400 years. So in 2009, the Christian philosopher William Lane Craig was actually expanding on some comments he'd made about animals and suffering. And he had this to say. Thus, amazingly, even though animals may experience pain, they are not aware of being in pain. God, in his mercy, has apparently spared animals the awareness of pain. This is a tremendous comfort to us pet owners, for even though your dog or cat may be in pain, it really isn't aware of it, and so doesn't suffer as you would if you were in pain. Once again, complete nonsense. He's also not a minor philosopher. I've heard that he's been included on some list of the 50 most influential living philosophers, particularly in the philosophy of religion. But this is obviously still a view that's going around. But maybe philosophers are detached from, the physical world. And you'd expect maybe an organization that's involved with animals will be a bit more realistic. Unfortunately, that's not the case. So just last year, the Ontario Federation of Agriculture was pushing an ag-gag law in Canada. And this is one of those laws where basically they want to have some protection that will stop activists from filming and documenting the conditions that animals live in, particularly in factory farms. And in their motivation to the court, what they said was, we simply do not know if animals are capable of reasoning and cognitive thought. Therefore, we cannot attribute human qualities of reasoning and cognitive thought on animals as the activists would like. And as has been sort of the pattern in this slide, that's nonsense. It's also more depressing because Agricultural Federation should have some in the studies of animals. So what's a more modern scientific view? In 2012, people gathered for the Francis Crick Memorial Lecture, and a number of neuroscientists and related professions were there, and they all signed a document which was called the Cambridge Declaration on Consciousness. And when we get near the end of that document, what it says is this: consequently, the weight of evidence indicates that humans are not unique in possessing the neurological substrates that generate consciousness. Non-human animals, including all mammals and birds, and many other creatures, including octopuses, also possess these neurological substrates. So, although it's a bit not as strongly worded as one might hope, it basically is saying that humans are not unique, and we can expect that most animals will also be conscious. There's no reason to think they are not. It's, of course, completely different to the views that we saw before. And what I want to do now in the rest of my time is basically go through some of the evidence that supports the ability of animals to think and reason and feel. And so we're going to start with intelligence, which is basically the ability to use your information and make some sort of conclusion, to use tools to manipulate the world and that sort of thing. And interestingly, tool use will feature in this, and that is one of those properties that used to be considered unique to humans. It was humans use tools, other animals do not use tools. But that distinction is not quite true. So we'll start off now with crows. So birds, particularly crows and other corvids, are quite intelligent and have been used in many of these studies. So what you're going to see first on the left is, excuse me, a crow which has a food reward in a basket which is inside a tube, and it cannot reach that tube. And what was going on in this study is birds were being presented with either straight pieces of metal or pieces of metal that were bent into a hook. And in this case, we have a crow that's been presented only with straight pieces of metal. So let's see what happens. So there you can see the tube. There's the basket at the bottom with the food reward. And obviously using a straight piece of metal, it's practically impossible to actually get the basket up. But now things get interesting. She hooks the metal inside the tape that's holding the base, and she bends this piece of metal, bends it into a hook. And with the hook, she can obviously take the basket out, and she's got access to the reward. And what's especially nice about this is that, as far as the people know, she was never shown how to bend a piece of metal into a hook, and she's never seen anyone doing it. This was something she came up with completely by herself. So clearly, animals can think, they can manipulate an item, change how it is shaped so that it'll be more useful for them. And it's not just single pieces that can be used as tools. In the next video, we'll see another crow where the food is again out of reach, and it's also out of reach with a single tool. But you can combine different tools to make a longer, well, sort of combined stick. So let's see how that goes. In this case, the food's in the box that's on the right. It's already got one stick in its beak, and there's other tools on the left-hand side. So you see it there combining its current stick with another tool, and then it can reach in to move the food out of the box where it can access it again. So basically, we have simple tool use, or it's not even that simple because it's manipulating the shape, plus then complex and multi-part tool use, both by crows. And it's not just the ability to use tools, they also obviously have an understanding of how the world works around them. So in the next video, it's basically 6 short experiments showing the successful trials. And this is, we're basically testing how well crows understand water displacement. So, you know, if you put something in water, it'll raise the water level. So what we see here in the first experiment is 2 tubes, one with sand, one with water, and a food reward again on the surface of these objects. And it can drop rocks into the tube. And obviously, if you drop rocks on sand, it just sits on the top. If you drop them in the water, you'll slowly raise the water level until you're able to reach whatever's floating on it. I think in this case, it took 3 rocks to actually be able to reach there. Okay, so successfully put the 3 rocks in. Yeah, I think you can reach it now. Yeah, there we go. Light versus heavy. So in this case, it's got, I'm not sure if they're wooden blocks, or probably not wood because that would float. So maybe some stone blocks and polystyrene. So obviously, again, polystyrene blocks will float. So that's not going to help. And actually, the next one it picks up, you'll see is too light. It just discards it immediately. Goes to the next one. Solid versus hollow. If the object is hollow, the water is obviously displaced, but I think they still weigh the same. And then narrow versus wide. So obviously, the wider a tube is, you're going to have to put in to raise the water level. So in this case, it starts putting things into the wider tube and presumably notices it's not having much effect and then moves over to the narrower tube. High versus low water level should be pretty self-explanatory. In this, though, it also reverses because it looks to me like the high water level is wider. And in the last experiment, there's 2 larger tubes, one small one which has the food reward in it, but only one of the larger tubes is actually connected to the food reward. So the other ones are empty or a blunt end. So it tries that one. Not much is going on. Moves over to the red one. And once again, we have success. So were these just flukes, basically, or was there some sort of understanding? When they looked at the number of correct guesses, they saw that for most of these, there seemed to be understanding of what was going on. So along each bar, as you go along, 1, 2, 3, 4, 5, 6 are the different experiments. And the height of the bar is showing basically the average number of correct choices, or the average percentage of correct choices. And those which have a star are either significantly above or below the 50% line, which is what you would expect just if it was making choices by chance. And so for 4 of these, it really understood what was going on. For the narrower or wider tube, it apparently did not understand because most of its choices were actually incorrect. And for the U tube, where it was joined invisibly, that was just sort of chance effect. So this would suggest not only can the crows use tools, but they understand how the physical aspects of the world actually work. But what if you needed 2 individuals to complete the puzzle? So it'll be a bit more complicated. You need cooperation now. And what you can see here is it's a setup where there are food rewards on a moving platform. And by pulling the rope on both ends, that platform comes forward, and in this case, the wolves can access the food reward. If you only pull on one side, what you're going to do is just completely out of there, and it'll be impossible to get the food reward. So in the videos that follow, the wolves to this alone, but with long enough rope that they could pull both ends by themselves. Once they knew basically how this was working, it was then they had shorter ropes and were sort of introduced to doing it with other wolves. So what you can see now on the left is a video of what happens if you have both wolves released at the same time. There is a bit of a delay because in the original video there's some narration of the date and the identity of the wolves. There we go. Perfectly pulled it together, got the reward. But maybe, you know, they're just, if they're released together, maybe they're just really excited, managed to get everything done by chance. It doesn't necessarily mean that they understand the concept of what. So the second experiment that was done here, or that is shown here, is a delayed release, where they release one of the wolves first, then wait 10 seconds and release the second wolf. So here you need to, the first wolf needs to know, okay, I can't do the partner and be willing to wait for the partner. So you can see already it's not running up as quickly as before, and it's waiting, even looking back for the partner. Again, they managed to cooperate and get the treat. So we've got a sort of understanding of how the puzzle system works. And actually, there was, I think, in the original study, one wolf that was pretty bad at doing this, but otherwise, all the others in their pairs were very successful. We're talking sort of 80, 90% of the trials getting it done. And on the delayed release, it was still, I think, above 60% that were getting it correct each time. So that's good. It's not only wolves that have been able to do this. Obviously, wolves are good on a cooperation test because they work in packs. But this same setup has been done as well with elephants and keas. Keas are sort of New Zealand parrots, and they were all able to do it successfully. In fact, there was one elephant that managed to do it alone, and she figured out that if you stand on one end of the rope, you can just pull the other one, and you don't need a partner to solve the puzzle, which is not quite the intended solution, but if it works, it works. And this next video is a bit more for fun. Basically, it's rats driving cars, and they were trained to do this over a fair amount of time, you know, getting them used to the containers, getting them used to the cars, and how it all functions. And in this case, by holding on to the wires that are either on the side or the front of the car, they're able to complete the circuit, and it will obviously move. And so you can see them here controlling this car in order to get to a food reward. And what I want to bring up with this is kind of that rats are also quite intelligent. There's a nice video from America's Got Talent where someone has a trained rat running across like a sort of obstacle course, which is quite nice to watch. But the point here is that you don't want to keep animals in sort of just a bare cage where there's no mental stimulation. They should get something that keeps them thinking. And I mean, if you can build, obviously, a car that a rat can control, that would be great if you have a rat and those skills. But certainly, just remember that these things can do a lot more than you probably think they can. So there we go. Okay, so that was fun. But then enough about different puzzles. Let's move on to language. So language is also something that people have said separates humans from animals. But all animals obviously need to be able to communicate. That's not always going to be a vocalization. As you know, there's also a lot of scent use for communication. There's also a lot of body language. And some people think also vocalization broadcast, like, oh, you see a predator coming, you sound an alarm, basically shout out to everyone, and that's kind of the limit of animal communication or language. But that's not the case. Also, I will say before we continue, learn a bit about animal body language, especially if you have a pet, so that you can better communicate. Because sometimes animals are actually a bit better at this than humans are. So you know how cats meow to communicate? Well, that's actually something that only really kittens do. Kittens meow. Cats don't meow to each other. They only meow to communicate with humans. So they already seem to be making a bit of an effort. So perhaps we can also make an effort. It would be a bit weird to talk about animals and language without talking about Alex, the African grey parrot, and Coco, the gorilla, because you've probably heard of them at some point. It would be very difficult not to if you've read anything about animal intelligence. So Alex was able to obviously speak in English because birds can make the same sort of vocalizations as humans. And he had, before he died, around 100-word vocabulary, but also an example of conceptual understanding, at least given the questions that are asked and the responses that were given. He also seemed to have come up with his own word. So there was some story that he was calling apples banaries, which they decided was actually a combination of banana and cherry, which were two fruits that he had words for, but he hadn't ever learned the word apple. And Coco was not able to speak any English words, but she was trained to use sign language and had a vocabulary of 1,000 signs and was said to have understood about 2,000 English words. She's also not the only gorilla, and I think not even the only ape to have learned sign language. There are many others, but she was obviously the really famous one. And she also had pet cats, actually, in her enclosure, and there's a picture of her with one of the kittens. But a more recent animal which has been learning the English language was Chaser. Border Collie's been described as the smartest dog in the world. Unfortunately, she's also passed away now, but she knew over 1,000 toys and various other words, including commands and categories of items. So she could understand the difference between a specific toy and a category of that toy. So that's pretty cool. She also seemed to be able to do inferential reasoning. So there's a nice video, which I was unfortunately allowed to play it here at the risk of getting the stream shut down, where Neil deGrasse Tyson goes to meet Chaser, and he first takes a couple of the toys at random out of a pile of 1,000 toys, and asks her, please fetch whatever this toy is, fetch that toy, and she does that all very successfully. Then he asks her, can you fetch Darwin, because he bought a Darwin doll and then hid it amongst the rest of the toys she was looking through. And it took her a lot longer, but eventually she did correctly bring Darwin. And that seems to have been inferential reasoning, where she had to fetch some toy. She was looking at the toys she had to go through. She knew that one, it was not what she had been asked. She knew the other one, it was not what she'd been asked. And then there was this one new toy, which she didn't know, and then put together that must be obviously the correct toy. So what we get here is certainly a fairly advanced usage of human language by a non-human. And an interesting product, actually, that relates to this is Fluent Pet, which I think was only launched last year. And it's basically a set of buttons with a symbol on the top that relates to a place or an action or an object. And by pushing on it, a pet is able to make the button say that word. And so by teaching them what the different words are, you're able to help it then communicate with you by using sort of the button to say words. And it's actually interesting because it comes from a technique that's used in speech therapy. So when they're autistic children or children with some other communication disorder, they can have a sort of visual board which has pictures of objects and other things that they might want to refer to, and they're able to then point to that to communicate. And that can be really nice for those children. And now, of course, it's being adopted for pets. And we'll see, it's not scientific yet, but they are, as far as I understand, planning to do some sort of scientific paper on this. So it's certainly something I think that's worth looking out for. And there's a channel on YouTube called Billy Speaks, where there's a cat using similar button. It's difficult if it's not scientific to know how accurate it really is, but it's certainly nice to look at. So what about, animal language that has got nothing to do with humans, just their own form of communication? And there was a study I read about bats, I believe Egyptian fruit bats, where they had a camera and a sound recorder in their roost, or whatever you call a bat house. And they recorded, a couple 100,000 vocalizations, used the video to identify who was saying that, was being said, and all that sort of information. And by then using machine learning, what they found was they could make very accurate predictions on which bat was saying something, the context in which it was being said, and the response of the other bats to that communication. So you can see a prediction of which bat it would be on the right. At the bottom, it's telling you the predicted bat ID and context. And on the left of that same figure is the actual bat ID and context. And the diagonal line going down from the top left to the bottom right is the accuracy of those predictions. So 0.8 in this sense means 80% correct. And what you can see is a lot of these predictions are really high. 80%, there's 90% out there. There's very few that are under 50%. And given the sheer number of possibilities here, to get predictions that high is definitely not just going by chance. And lastly, there was, with a fairly lower accuracy, they were able to predict which bat was actually being addressed just by the way the vocalizations are made. And this might suggest that bats have some sort of naming system, which is also something that's been seen in dolphins. So dolphins have a thing called a signature whistle, and that's a whistle with a pattern that is unique to each individual. And what the researchers found was that by playing a copy of a specific dolphin's signature whistle, which you'll see in this bar, the copy bar on the left, they would quite often repeat and match that vocalization. So that's the black part of that bar. Some of the time they would not respond, but most of the time they did. If you played them the signature whistle of a dolphin which they knew, they would sometimes reply to it, but most of the time not. And furthermore, if you played them a whistle from a dolphin they did not know, they would never reply to it. And the researchers argue that this is again showing that these signature whistles might be used as specific identifiers for individual dolphins. And so by using one signature whistle, you can say, okay, whatever I'm going to say now is directed to a particular individual. So that's really cool, that there certainly seems to be more information and specificity of that information in animal vocalizations. It's not just a broad warning call, look out, there's danger. And what about morality, right and wrong? Do animals have any sort of ethics at all? There is some evidence that they do. So there's an experiment that was done by the primatologist Frans de Waal, and you can actually, you can hear him talk about it in a TED Talk, where he had capuchin monkeys. And what they had trained them to do was they would take a rock that was given to them by the researcher and hand it back. And for handing it back, they would get a reward. And that would usually be a piece of cucumber. And they were happy to hand it back and get cucumber many, many times in a row. But the capuchins actually prefer eating grapes. So the question then became, what happens if you feed or reward one with cucumber and you reward with grapes? So let's see. Here you can see the monkey gives the rock, it gets cucumber, it's happy, eats that. Second one, they put the rock in the cage, gets the rock, gives it to the researcher, and this time it's given a grape. And the first monkey sees that, gives the rock, gets his cucumber again. But now he doesn't eat it. He's not happy getting cucumber when there's grapes there. Not happy at all. Second one takes the rock again, gives it back, once again gets a grape. First one, bashes it against the wall a bit, gets his cucumber, still not happy, just throws it back in anger. So what this is suggesting is that monkeys have a sense of fairness. They're not happy if they're doing the same task as another one, the other one gets a better reward. So, yeah, I think it's a pretty cool result, and certainly quite a response that first monkey gave here. What about empathy? So sympathy, or the ability to put yourself in a partner's position. So rats seem to be able to do that. So what you're going to see here is a video of a rat, a free rat in a cage, and a second rat which has a restrained cage mate in there. And the idea is that the free rat doesn't know how to the restrained cage mate, but it can obviously see the restrained cage mate, and it can hear the sort of distress calls because it's obviously not happy being restrained there. And this is repeated, several times to see whether it'll be able to figure it out. So after 5 days, the free rat does figure out how to open up this restraint. There we go. It's freed its cage mate. And now what's interesting is that the free one follows the cage mate, showing action. And apparently it did this for, I think, like 5 minutes or something. Because remember, rats are also quite social creatures. But this was still repeated several times, even after it learned how to cage or the restraint. So this is then the last opening, obviously. And it investigates basically the cage, sees everything's normal. And when it releases the cage mate, you'll see it's completely different. It doesn't fit around it. Now it's just business as usual. It's like, yeah, you're free, you're done. Don't need to worry about it. There's a sort of familiarity now. But they also did other trials as well. So the free rat releases a trapped cage mate much faster than it opens an empty restrainer. And in fact, in this study, it was releasing the trapped cage mate as often as it was opening the restrainer to get to chocolate. So that suggested that, okay, there was quite a high motivation to free its cage mate. And they even found that when there was chocolate, the free rat would share actually the restrained cage mate. There has also been some other explanations. So a repeat of the study did find that the rats would open free a cage mate more quickly than they would free or open an empty container. But it found that they would open it even faster for chocolate. So there's still a little bit to be discussed there. And some people say this is not an example of empathy in rats. It's merely an example of trying to get rid of a horrible stimulus. So if you don't like the distress sounds, it'll open just for that reason. So for example, maybe you'd give a piece of chocolate to, a screaming child on a plane, not because you particularly like the child or anything, but just to stop them from screaming. But of course, more needs to be seen. And with wolves, there's also some evidence that they can be generous, at least to their packmates. So in this case, wolves were trained to push a button on a touch screen, and if they did this, a second wolf would get a reward, and they could see the other wolf getting the reward, but they would get nothing out of this. And what they found, hopefully you can see my cursor, is that this bar over here, the in-group test, is where there was a wolf that they knew and were familiar with, and they were willing to push the button a lot more than if there was a wolf there that was not getting the reward. So they're generous to packmates with no benefit to themselves. And they did not display this with wolves that they were not basically friends with. So it was only ones in their in-group. And dogs basically got bored and didn't do anything because they were not getting any reward. There was some discussion about that, but we're keeping this fairly simple at the moment. And this is maybe not too surprising because they're social, they have to work together, but they also have a sort of bias towards in-group members. And that's something we also see with humans. You know, you're more generous to people that you feel are familiar in some sort of group, like to other furs, for example, rather than just random people on the street. And then I believe it's the so do animals have culture? And by this I mean learned behaviors which are passed on through generations. This is something that is not caused by genetics, and it's not caused by the environment. So if we look at dolphins in Shark Bay in Australia, what you can see on the left-hand side are dolphins with a sponge covering their nose, though technically it's called a rostrum. But they do this so that they can then push along the sandy, the bottom of the ocean where it's all sandy, and otherwise would be quite sharp and uncomfortable for them to sort of rub their noses in it. And they do this because there's some fish that lurk just underneath the surface of the sand, and they lack a swim bladder. So there's the same density as the water, and hence are invisible to the echolocation. But by pushing through the sand, you can disturb them and then get a meal. And this is something that appears to have been developed by a single female in Shark Bay and then passed on to her daughters. And people have looked at this in terms of the genetics, and it doesn't appear to be a genetic effect, and it's also not an environmental effect. There are lots of other dolphins here that are not doing the same behavior. Interestingly enough, it does seem to only be the female dolphins that are doing it, and they do have some reasons why they think that might be the case, but it's not particularly relevant in this talk. And lastly, what about bonobos? So they are sort of just as different to us as we are from chimpanzees. So bonobos and chimpanzees split off after they split away from humans. And what you can see in the three, these are actually maps. Here's my cursor again. These are actually maps. The white one shows one troops where it spends its time, and the dark gray one shows another troop of bonobos and where they spend their time. And what you can see here is that they actually overlap quite significantly in and where they spend their time. These troops actually also will interact. There's gene flow between them, so they interbreed amongst each other. So it's the same environment, same genetics. But what is interesting here is their hunting behavior. So what you can see is the Ikalakala bonobos are mostly hunting the Onamalura, which is a type of African squirrel. And they almost don't hunt anything else, at least that's mentioned in the study. Whereas the Kokorolongo, they're hunting sort of normal squirrels. I don't quite know what the difference is between that and a Malura and Deka. So in the same area, completely different behaviors. And this appears to be, again, a sort of cultural trait that's passed on. And in fact, it might even be passed on so that these two troops are not going to have competition for the same resources. So if obviously you're competing for something, it's going to put some strain on the relationship. Here they hunt different prey. There's no competition. Everything is all happy, and they can go about their business. So then to just sort of sum up what we've been talking here. So there's no question really unlike some of those philosophers at the beginning thought, over whether animals can think. They definitely can think. The only question is how much they think. And the answer to that question is that they're probably smarter than you think they are, unless you're really overestimating animal intelligence. But they're definitely, the tool use is not limited just to humans. It's fairly widespread. Sometimes complex tool use. There's cooperation to solve puzzles. There's the ability to knowledge to understand how the world works, and so on. Not only that, but several animals have the ability to understand human language, or at least taught to understand human language, and may even have their own form of language. There's a lot more specificity in the information than just a broadcast to everyone that can hear it. There's also evidence animals may have a sense of morality, some sort of empathy, generosity to their in-group members, a sense of fairness, basically. There's also evidence that animals, particularly in this case cetaceans, so dolphins and whales, and apes, may possess some sort of culture that's passed on between the different ones. This is, again, something you need a fairly high level of intelligence, obviously, and probably a decent amount of communication. Although I think a lot of it is just looking and observing what others are doing. And lastly, I think this is kind of just the beginning. So a lot of this work is fairly, and I think that's because of the prejudice that you had before, where if you think, okay, animals can't think or feel, they just sort of react like machines, you're not going to even look for any intelligent behavior. And now that people are actually looking, they're finding it. And I suspect we're going to find more and more evidence of cultures, of morality, of language, of intelligence and tool use among the different animals. I think also what would be interesting is that we will get better in terms of our ability to communicate with animals and to help them communicate with us. So if you look at, for example, a human child, if they just grow up by themselves, they're not going to be able to do maths. You have to send them to school to do maths, and then they learn to do things. With that bit of learning, they can use it to learn something else and build up some sort of structure. So I think if we get better at teaching animals various things, we'll be able to push this further and further. And I think something then like those pet fluent buttons will be pretty cool to see. I guess one of the limitations will be if pet owners are actually willing to go through the effort of doing that. So I mean, just in terms of basic dog obedience training, like just sit, stay, come here, I mean, the really basic commands, there are a lot of them, especially in South Africa, that you know, they've never been taught to do that. And this is not complicated. It's the same. Cats are able to learn commands, but nobody puts the effort into it. Furthermore, if you look at dogs like Chaser, who knew 1,000 different words, there's no reason to suspect that she's sort of unique. She's just a sort of average dog. I mean, apart from being a border collie, which is a pretty intelligent breed, but she's otherwise just an average border collie. So this is a potential that probably all of those dogs have, and we just need to learn to unlock it. So yeah, that's then my talk. I hope you enjoyed it. And if you have any questions, maybe I can answer them because I still have, like 15 minutes left. I think there's a 20-second delay I've heard between in the chat and 20-second delay between what I say and what's typed in the chat. But yeah, so yeah, hopefully you enjoyed it. Any questions? I'll do my best. Although if there are no questions, this is going to be a very section of dead air. Okay, here's a question. How do you actually get a bead on intelligence for animals that don't cooperate, e.g. cats? So I think, again, like, as I said in the beginning, it's not entirely my field. So there are people that are just doing my best, but don't take my answers as sort of the final word there. I'd say cats, for example, they're not necessarily cooperative, but they can be trained to cooperate, and there is evidence that they do understand. So like I said, talking about the pet-fluent buttons, there's this YouTube channel for a cat called Billy, and the channel is Billy Speaks. It'll be linked, obviously, in the presentation. And so she's been learning a lot of buttons. And it's the same way you'd go with a dog, for example, to teach the button use. When something comes up, you push the button until she makes that sort of association, and then know, okay, if the button and it'll work the other way. You can also do intelligent tests with sort of puzzles. So like we had in the beginning with the crows and the wolves were cooperating, but you can have puzzles where they need to manipulate something and understand how something moves to get it. And there's actually some really cool devices that I see they now have for pets, where you have food, little food treats hidden in these contraptions that you have to open various different flaps and move things around. And so that's really good, both for keeping your pets happy and also helping mind. So obviously, if they're able to do that, it'll be, I'd say, some evidence at least for the intelligence there. There's a second question. How do you make animals not jippo the test like the elephant did? Do you just adapt your interpretation? Yeah, so that's actually, I think, if they can sort of solve the test another way, I think, because, you know, it's still figuring out how to solve the test. And that's pretty cool, especially when it comes to doing something like, okay, wait, I can just stand on this side and pull that side. I don't need to wait for a partner. That's a really nice sort of result to have. I mean, you can obviously design your tests a bit better, but I think this is, I mean, a similar problem I think they have in artificial. The algorithms will sort of figure out a way to get around the evaluation, and it's sort of in sometimes very odd ways. But I mean, whether something solves the test the right way or not, either way, you get a sign that they're actually thinking things, understanding how it works, and then using that to get to a reward. Let's see what else. Blue Nadir is saying, not too confident about Billy Speaks, whether it's legit. Yeah, I agree. Like I said, for example, they're not scientifically tested yet. So we don't know how accurate it really is. I suspect it can be true that Billy really knows what the buttons mean and is using them. But you need to have proper control tests. That's why the vast majority of what's here is from scientific papers where they actually have, they repeat the thing enough times that you can really see that it's happening. So I'd encourage, I mean, if you really look at some of the papers. In terms of color blindness, I think it came up here. I'm not sure if cats are colorblind, but it also, I think they put a lot more in sort of the pattern that's on there. So they certainly. Oh, I think I missed a question from Ivik. Humans have been unknowingly seen to teach animals. How does one get beyond that scientific bias? Yeah, that's difficult. I guess it depends on what you're actually testing. If you're bringing in a new thing that that the animal wouldn't have had a chance to see or to see you doing, then you can say, okay, there's definitely not. It's not doing it because it's seen someone doing it before. But I mean, that's going to be very dependent on what your test is. I mean, when it comes to bending a straight metal piece into a hook. That's something that an animal could potentially have picked up somewhere. I'm not sure if the crows were sort of captured from the wild or were captivity or not. But that was one example where they were saying they are not aware of the crow ever bend a piece of metal into a hook. So that's something at least. I think in other cases, yeah, you just got to come up with a weird test. I mean, for example, pulling that platform, it's unlikely that you're going to encounter that anywhere else, especially just if you do it with pet dogs. So pet dogs apparently also perform better than the dogs that were compared with the wolf thing. In that case, I think all the wolf experiments done. There's a wolf research center just outside Vienna, Austria. And they've also got dogs that are living basically, they're living in packs, not as sort of pets in houses. So there can be a difference depending on how animals are living. Incidentally, they think that might be a better representation of dogs because apparently 80% of dogs actually live as free-ranging packs and not as pets, which is quite interesting in itself. Yeah, it's just a comment on cats being intelligent and things. Yeah, you also get a lot of these threads of like, what's the thing your pet's ever done? And you can get really interesting examples. The problem is you always run with that. There's always the risk of, is this something that's true and not made up? Or is it being completely misinterpreted? Like, I mean, there were some of the stories you would believe, like, oh, the cats, it got disturbed by some loud noise, went into the room and yelled at the person who shouted or something. That, I could believe. I saw some other story like, oh, I was, young and I was choking and my cat sort of ran at me and dived into my chest and sort of performed the Heimlich on me. And that seems quite unlikely. I would believe that story. But there's other ones about, for example, octopuses that have escaped from their tanks in aquariums and done all sorts of cool stuff. And those sound like really interesting stories, but I wasn't able to find a sort of reliable source for it. So I didn't mention any of those here. Although, speaking about octopuses, there was a South African documentary on octopuses called, or at least the relationship between one diver and a wild octopus, called My Octopus Teacher, which has apparently been nominated for an Oscar. And Sudan has apparently said, well, not apparently, he did say in the Telegram that it's a really good documentary, but I haven't watched it myself. Is there, let's see, any other questions I might have missed? Or that seems to be all of them right now. Yes. No, I think we can switch over to music then. I think that's good. I don't know if people can hear me now talking, so I just want to say thank you to everyone for listening, and I hope it was interesting and informative. And also thank you to all the organizers. Yeah. That's everything from my side, I think. Okay, bye.